In the Grand Ronde area, harvesting native plants deeply connects to the heritage and the land itself. These plants sustain native peoples, offering food, medicine, and materials. By cultivating them now, we get to honor that legacy that has supported them for generations. These native species create vital habitats for local wildlife and strengthen our homeland's natural balance. Growing them is an act of respect for our past and an investment in a thriving future for the Confederated Tribes of Grand Ronde. That is why one part of our project this year has been to plant community gardens with a variety of native plants at 3 public parks in the Salem area: Englewood, Woodmansee, and David Sawyer Park in Turner. Native culture has been clouded and undermined while the United States government was taking lives, land, and resources. This has caused many cultural values to be forgotten, which is why learning and educating about this topic is key to preserving it. Native first foods are still a huge part of Native American culture today. The lack of respect and consideration our country has for Native Americans is causing younger generations to leave hundreds of years old traditions behind. Imagine many different families, each with their stories and traditions. Then the government forces all those families to move to one new place far from their homes. That's what happened to the tribes who became Grand Ronde. They were strong and tried to build a new life together, holding on to their memories and cultures. But then the government said, "You don't exist anymore," telling those families they didn't matter. But those families never gave up. They fought back for years to be seen and heard again. And they won, getting their recognition back. For the 2024-2025 school year, my group is studying the first foods of Native Americans. We have 3 research questions, 1 long-term for future groups to answer, and 2 for only this year. The long-term question is how long does it take for Comicia leglenii and Comicia quamish bulb to develop seeds? How long for those seeds to develop and divide? As a group, our hypothesis was that they would divide in 3 to 5 years. The first short-term question is how does fire affect the growth of camas? And the second is if you divide a leglenii bulb in half or in fourths, will each cut bulb create its own camas plant? For our second question, we hypothesized that the burning would be good for the plants, and that they would grow sooner or at least show signs of being more robust. For our third question, we predicted that the cut bulbs would still produce plants since the bulbs naturally split on their own later on. We suspected that not all split bulbs would survive, but that enough would survive that it would increase the propagation of the plant. 2 of our local stakeholders are the Chachaluk Grand Ronde Museum and the Grand Ronde Native Nursery. These local stakeholders are continually striving to produce and introduce more native plants around Salem. Other stakeholders are parkgoers and members of the community. They will encounter the community gardens that we planted and will be educated about why these native plants are important to our community.
The Grand Ronde is a group of Native American tribes and bands with over 30 different tribes from the West Coast. They were forcibly removed from their homeland to a reservation. It was initially much larger, but now is 11,500 acres, and they lost about 49,500 acres because of government actions. Now they are one of the recognized tribes in Oregon. To this day, they are committed to responsible stewardship of the land and to preserving tribal cultures and traditions. This includes traditions of burning, forestry, fishing, language, and art forms. Oregon has many first foods, but we chose to focus on camas for our research. Common camas, or Comicia quamish, is one of the most important native foods for the Salish people. You can eat camas baked, roasted, dried, or raw. Natives also use camas as a sweetener for other foods that they ate. It is found throughout the Pacific Northwest and historically grew in prairies that families would care for. It can be identified by its dark purple flowers and thicker leaves, but be careful because of the bulbs of a very similar plant, death camas, is poisonous and can look almost the exact same. We had a secondary focus on narrowleaf onion, biscuit root, yampa, and brodia for our community gardens. Narrowleaf onion, Allium implectans, and wild onions, Allium species, were widely utilized across North America. Indigenous peoples commonly ate the bulbs and leaves raw, cooked in various dishes, and preserved them for later use. Medically, crushed onions were applied to bites and stings, and the syrups were used for coughs. The bearstem biscuit root, Lomatium nudicale, is in the carrot family. Found in Western North America, it was used by Native Americans not only for food but also medicine. Yampa and Peridardia oregana is part of the carrot family. Yampa is brownish gray and the yampa bulb is about 2 to 4 inches long and can be eaten. Yampa roots were eaten roasted, boiled, steamed, dried, or raw. Rhodia, also known as cluster lilies, and is a good source of fiber.
Over the last few months, we've learned so much about the Grand Ronde tribes and the culturally significant foods. We were also able to get hands-on experience working with these plants. When we were out in the field, we used a lot of different tools and materials to conduct our research, including buckets, rakes, shovels, hose, gloves, water, and even newspapers. We also used wheelbarrows, notebooks, and flags to mark our planting areas. And of course, we worked with lots of different bulbs and seeds like camas, narrow-leaved onion, yampa, and bare stem biscuit root. Our first trip was on November 1st to the Chachalu Museum and Cultural Center, which is located on the Grand Ronde Reservation. We got to take a really interesting tour of the museum, where Crystal Starr Fullerton helped us learn about the native culture of the Grand Ronde tribes, as well as explained how native plants like camas grow and spread. After that, we went to the Grand Ronde Nursery. Jeremy Oyua, who heads the Grand Ronde Nursery, taught us even more about camas and how it can still grow even after being divided. He also offered us insight into the challenges that he faces with restoring native areas. This information helped us come up with our research questions. Lastly, we worked with Jeremy to dig through trays of native bulbs. After that, he sent us home with bulbs for yampa, narrow-leaved onion, rhodia, bare stem biscuit root, and camas. Our second trip was to David Sawyer Park on November 15th. We picked a spot for planting our native plants garden, marked it off with flags, and cleared out all the grass and weeds. We laid down newspaper, added soil, watered it, and then planted our camas, yampa, narrow-leaved onion, rhodia, and bare stem biscuit root. On November 25th, we went to Inglewood Park and worked alongside other JGEM students. We also met with members of the Inglewood Volunteer Group and the City of Salem workers. This was our second native plants garden and will be in addition to an already existing restoration planting area in Inglewood Park. Our last field trip was to Woodmansee Park on December 11th. We met with the City of Salem workers at the park and they showed us where our planting area will be. At this planting area, we did not clear out any of the plants or weeds, but instead we planted directly into the designated bed. Since it had rained recently, the ground was already moist, so we didn't need to water anything. Back at school, we conducted our camas research. We planted bulbs on October 19th, 2024. We used the same planting protocol for each variable except for the designated treatments. We first planted one crate with whole bulbs. This acted as our control for both our question about cutting bulbs and dividing bulbs. Next, we cut 5 bulbs in half and planted the 10 halves in a crate. Then, we cut 3 bulbs and cut them into quarters. We planted 10 quarter bulbs in a third crate. Then, we planted bulbs in a crate to use for the fire treatment. In our observatory space, in 2 other crates, we planted common camas seeds to use for our long-term question, which future first food groups will explore. After planting, the next task for us was to conduct our burning experiment. We burned the surface of the soil with a blowtorch for 5 minutes every week starting on December 5th until we noticed germination on January 14th. We burned the camas every week until germination. First, for our control, we would observe how many bulbs have germinated and record that number. This was recorded as our control for both the burning and cutting variables. We determined germination based on whether there was any shoot visible in the soil. At the next crate, which contains the half bulbs, we would observe how many had germinated. Then we moved to the crate which contained the bulbs that were split into fourths and record our observations. Next, we would look at the crate that had been burned. We then looked at how many bulbs germinated and noted any other things that were out of the ordinary. For the final part of the project was to make signs for parks where we planted. We each wrote short descriptions about the plants, and then Galena designed the signs in Google Docs. Those signs will be placed in each park to help teach others about the native plants we've been working with.
Our findings for each of our research questions surprised us all. For our first question, we wanted to know if we could cut bulbs in halves and quarters. To figure this out, we divided our bulbs into 3 sections. One group of whole, untouched bulbs as a control, one group cut in half, and another third group cut into quarters. All of the bulbs in the control group sprouted successfully, but in both the halved and quartered groups, only about 4 out of 10 bulbs germinated. This indicates that cutting the bulbs had a negative impact. We originally thought slicing them further into quarters did not make things worse, but later we found that some of the sprouts we had thought were from bulbs could have been from seeds that blew over from 2 groups that were growing camas from seeds. Our second question was, how does fire affect camas? In late January, the temperature dropped significantly. During this, we observed that the soil froze over with ice. For a week, we could not see anything from our burned group. Interestingly, though, we were able to locate about half of the sprouts in the control group that had previously germinated. Despite the difference we had noticed at first, in the end, all bulbs for both the control and burn group had sprouted. This highlights the significance that long-term monitoring has on data collection. Had we stopped our collection, we could have come to the conclusion that the burned bulbs had failed to germinate. For our long-term question, we planted seeds of both great camas and common camas. This study will be continued for years to come by the Garden Club and future 8th grade research groups. Our goal is to discover when camas bulbs split in their life cycle. We have no clear answer to this question, but observe the seeds as they sprouted, as seen in this data table. Our original hypothesis was that out of all the bulbs in all of the groups, the burned would do the best. Some of us originally thought that this was because controlled burning is an old process and tradition that some Native American tribes used to clear the land they lived on. This proved to be slightly incorrect. All of the burned bulbs germinated but grew a lot slower and less than the control. We also predicted that the cut bulbs would do well. However, it turned out that the cut bulbs struggled to germinate.
As we reviewed our findings, one surprising trend emerged. Many of our control groups outperformed the test groups. This was particularly evident in our first group, which is our split in halves and fourths group. We had high expectations for success, but the results didn't align with our hopes. For this question, we discovered that the bulbs that were cut were very delicate and weak, but technically, some of them created their own camas plant. Initially, it seemed that 4 bulbs were going to sprout from the 10 quartered bulbs, which would be an encouraging success since we started with 2.5 full bulbs. However, in April, we noticed that 2 of these plants died. Our most recent May observations show that all 4 plants have died, perhaps gone dormant for the season. We should continue to monitor those bulbs in the future. We believe cutting the bulbs in an effort to increase propagation is not an effective strategy, though our sample size was small, so more research is needed to confirm these results. For our burn group, we found that the germination process was just slower than the control group, but that all bulbs germinated. This indicates that burning has a neutral or positive effect on the growth of the plants. Following the plants for a longer period of time would indicate the long-term effect of burning on these plants. For our third research question, regarding how long it takes for Camassia laxlinii and Camassia quamish bulbs to develop from the seed, then to develop and divide. We don't have enough evidence to answer this question yet. In our observatory, focusing on camas seeds, we had 19 seeds that also germinated. However, it's worth noting that in this group, despite some germination, the seeds that sprouted were quite fragile, small, and brittle in nature. This brittle nature of the seeds is to be expected. As we delve into these findings, we have an opportunity to explore these results in comparison to other studies. One paper noted that the daughter bulb, or newly formed bulb, of great camas grows during its summer rest and needs winter chilling for leaf emergence. This approach of combining heat and chilling is fascinating compared to our reliance on heat alone. Manipulating native plants to emerge multiple times a year could enhance their production. As a group of 5 8th graders, we faced challenges such as possible human errors in data collection. We could have easily miscounted germination or written something down wrong. We were also limited in our space for conducting this research and by safety constraints regarding our burning practices. Nevertheless, we're actively participating in conservation by planting native species in local parks and educating others about Native American culture. Our outreach is supporting community learning and conservation. The Department of Environmental Quality awarded us a grant to purchase a greenhouse, enabling us to continue researching the most effective methods for propagating camas. We are cultivating our own supply of native foods to support our efforts. We are continuing this research to enhance our understanding of the best propagation methods for mass-producing native species. Some of the ideas that future researchers could explore are to compare planting in the ground, more like Native Americans would have done, versus planting in crates, like we did. They could also compare the impact of cooling and heating the bulbs, as well as the timing of burning. We would like to thank Mr. and Mrs. Weddle, Izzy Mason, Jeremy Oyuwa, Crystal Starr Fullerton, Christy Olson, Ruth Ames, and the panelists. Are there any questions?
When you were saying burn, do they burn after they're planted or before?
After. Panelists, questions?
Yeah, all right, Raleigh, Galena, Layla, Braxton, Sabrina. Yeah, look it out. Love memorizing. Awesome, great job. I love coming to these presentations because I always learn something new. So thanks for teaching me more about native plants. Some questions. So when you were planting the bulbs, did you plant them a certain width distance apart from each other in each variable, or did you just kind of pick and choose a spot?
But we just put them randomly.
Do you know did you research if they need to be a certain distance apart from each other to grow more successfully or not?
When talking about the burning, did you do any specific research on like if the neutral impacts that you saw were just specific to the plant you were looking at, or if there were maybe other plants that would have reacted a lot differently to burning?
We didn't look up that a lot, but
I think when it comes to burning, there are some plants that would get harmed by the burning and they catch on fire, but it just so happens that camas doesn't.
Awesome.
I have a question. So, when, like, you were cutting, I don't know anything about this, so, when you were cutting the seeds in half and quarter, did you guys do that because that's how indigenous people used to do it?
It was a method that the indigenous people used to use, and so we decided to try it to help us propagate better.
And how does that work? That is better if you cut it? Is there just not that many seeds? Or bulbs in it?
well, they would naturally divide on their own in the ground, but we had to rush this process a little bit because it would happen more over each planting process that we would do. So
So part of our project is to try to figure out how to grow more camas and faster. So we were wondering if splitting them could, increase their propagation, just so we could have more.
All right, another question. Congrats on the Department of Energy grant for the greenhouse. That's really amazing. Is that something maybe in the future you think you could utilize for possible native plant sales for the school to help get more native species
So you worked with a lot of different partners and collaborators for your project. Are there any specific lessons you learned that really helped you understand why it's so important to work with collaborators and how?
I would say one of the collaborators that we worked with was the Chantilly Grand Ron Museum, and I feel like it was really important because culture is really important, especially nowadays, and it was really important to the museum and their like native peoples, so it's important to us as well.
Any other thoughts on that question?
So when working with the people who helped find the public parks that we were going to plant in, there were only there were specific places we couldn't because they were sacred grounds. So they helped us kind of figure out where those spots were when putting the sign down and planting things. So they helped us with doing that, and so we got to learn a little bit about that.
Awesome.
Do you know if there are other plants that they also did that have also had the history of like been the cutting the bulbs into halves or quarters? Do you know if there are other plants that method has been useful for?
Just to briefly clarify, the Native Americans didn't cut the bulbs. The bulbs naturally split over time, and when they split over time, they would separate them after they naturally split. Like Galena explained, our objective with cutting them was to try and see if we couldn't speed up that process because they have trouble. The Grand Ron Reservation nursery has trouble meeting demand for camas, and so they're trying to find ways to propagate it more quickly, and that was part of the question. The burning, however, is a native practice that we were attempting to replicate as best we could.
I have a question, if it's not the if I can interrupt the panelists. Did you guys did you eat any of the camas? Did you try it?
We did. Yes, we ended up eating one of the considerable wild carrots called yamba. It tasted like a carrot. I don't know.
Thanks.
Any other panelist questions before we see what time we have?
There's a shortage of camas now, like for people that want to get it. So are you guys planning in the future that you'll be able to like add to the supply with like greenhouse?
Not with our greenhouse, but it's just we're trying to figure out ways to help other nurseries grow more.
This may be an easier question to answer, but I saw on one of your planting sites that you put down newspaper and cardboard first before you planted anything. What was the purpose of that?
It was more to help protect the soil for the camas and help the plants decompose in the form so it can have more of an impact and a faster growing period.
What was the most impactful thing that you learned while working with local indigenous communities? And this can be impactful to the project or just to you as a person.
I think just the importance of their native plants. It really means a lot to them. I think probably they haven't been able to because of colonization. They haven't been able to keep a lot of the traditions that they had, and so just the impact that colonization and all those things. I think it really meant a lot to learn about that from other Native American people and their side and everything.
Adding on to what Galena said, I think we had an amazing opportunity to like learn that camas was such high demand and so were other native plants and like how important they were for the community that nobody realized.
Anybody else want to answer their own perspective on that question?
I believe that it was a very amazing opportunity to be able to go and get a tour of the museum because we learned so much from it about all the different native plants and how the burn burning worked. I just thought it was nice.
All right, we've got about 1 minute left. If there's any last questions, either from Mr. Weddle or the audience. Yes,
Yeah. No, go ahead.
Sarah.
The signage, did you guys put signs at every park?
All of the parks we plan to have.
I have a question. Those little kids there are not from J. Jones. Tell us a little bit about who those kids were and what that experience was like.
They were, I'm pretty sure, second graders from Inglewood, the Inglewood school, and we taught them a little bit about the native things.
And then they planted some stuff as well in the park. Yeah, pretty cool.
All right, thank you so much. Let's give one more round of applause. If J. Jones 6th and 7th graders, you guys can head out first. 8th graders, this is our break time. Your primary space to take a break is going to be outside, unless you need to use the restroom. Okay? Parents, thank you so much for coming. You can make your way out at your leisure. So let's go outside. Unless we're using the restroom, 8th graders are going outside. This is when sea otters go to my room, and then from this you'll go to my room during their food. So sea otters can head into my room. Please be careful. I'm sorry, I did not say this.